Assalamu alaikum. Now we will start chapter 6. Section 6.1 is about areas between curves. Well, our aim in this section is to find the area bounded by two curves. See, for example, this figure. This is y equal f of x, this is y equal g of x, closed by x equal to a and x equal to b. Now we will split this section in three cases. Case number 1, the area A of the region bounded by the curves y equal f of x and y equal g of x and the lines x equal to a, x equal to b, where f and g are continuous. In fact, you can see this figure or this one. As I said, this is y equal f of x, this is y equal g of x, this is x equal to a, and we close it by x equal to b. Well, and also f and g are continuous. I think these are clear. He said also, and f greater than or equal g of x for all x in AB. We can see it clearly here. This is f of x, always greater than the lower function g of x. He said the area A is equal the integral from a to b, f of x minus g of x dx. Good? This is the rule here. And in short, he said it is the integral from a to b, y top minus y bottom. That means, do you see this f of x? It is the top function minus g of x, which is the bottom function. And we need to integrate with respect to dx. Well, I said here, small x and big X. Why do we need this? Recall, if we say integrate with respect to x, that means you need to integrate from small x up to big X in your region. This is our smallest x in the region, and this is our largest x in the region. Please read on the x-axis. Good. Why did I say here solve for y? Because if you solve for y, for example, y minus x squared equal to 0. If you solve for y, what do you get here on the right hand side? You get x squared. That means it is a function of x, and you integrate with respect to x. That means everything is working fine. Now we will see the justification together. Why did we say y top minus y bottom? Why it is not the other way around? First, we need to divide the region into n strips of equal width. Delta x equal b minus a over n. As we said before, this is your interval AB. Partition it uniformly. That means this is your x0, x1, x2, etc. until you get xi minus 1, xi, move until you get b, which is equal xn. Now divide this region into n strips and create your rectangles. For example, if we are in this interval xi minus 1 up to xi, let us form our rectangle like this. You see it here? Here you can take right endpoint, left endpoint, any sample point. Create your rectangle number 1, rectangle number 2, etc. Now, question, what is the area of the ith strip? It is AI approximately height times width. What is the width? It is xi minus 1. Clearly, it is delta x because we use uniform partition. Next, what is my height? Do you see it here? It is f of x minus g of x. But at which x value? For sure it is what? xi. Because here I said right endpoints. So here I will write f of xi minus g of xi times delta x. And to illustrate further, this is the height. And this is the width. Is this clear? And we said here using right endpoints. In general, it's not necessary to take right endpoint. You will write f of xi star minus g of xi star delta x, where xi star lies in this interval. After that, as we said, we have rectangles to the right here and to the left. So add the areas of the approximating rectangles. What do you get? You will get approximation of the area. The area A approximately equal summation I equal to 1 up to n f of xi minus g of xi times delta x. You just add them up. A1 plus A2, A3, etc. and until you get AN. Number 4, the approximation appears to become better and better as n goes to infinity. If you have more rectangles, then the approximation will be better. If you need things to be exact, you need to push the number of rectangles to go to infinity. That means A and C, the notation, equal the limit when n goes to infinity, summation I equal to 1 up to n, f of xi minus g of xi delta x. And let us close it here. Now wait. Limit of summation is equal to what? By definition, this is the integral from A to B, right? See the figure here. F of xi will become f of x minus here g of x, and delta x will be dx. That's it. So we get the same formula. This is the top function. I will call it y top, yt, and this is yb, y bottom. And that's it. But this is the justification of the formula. Here we have a question. Is there any difference if we choose f of xi minus 1 minus g of xi minus 1? This student is saying that, can we replace I by I minus 1? It's correct, you can do it. You are using left endpoints. Remember, in section 5.2 we said if you push in to go to infinity, then things will be exact. The right endpoint definition will be the same as the left endpoint definition. They will match. But here, to make things easy, I just use xi. Here I have small note. Recall that the area is always positive, right? That means you need to integrate positive quantity. See it here, we are subtracting this way, top minus bottom. But if you subtract this way, top minus bottom, for sure you will get a positive quantity, right? But this is the reason for taking top minus bottom. Now let us see examples. Question 1, part A. He said find the area of the region bounded above by y equal ex, bounded below by y equal x, and bounded on the sides by the lines x equal to 0 and x equal to 1. First, you need to draw the region. This is step number 1. How can we draw y equal e to the power x? I think you know this from prepare. It's like in Arabic, حرف الراء. And we need to draw y equal x. Y equal to x is increasing function and it passes 0, 0, for example. So this is y equal x. Also, he said close it on the sides by x equal to 0. This is x equal to 0. And he said close it by x equal to 1. So I can close it this way, x equal to 1. But be careful, I need to close it here only. Why? Because this is my region. If I close it here, I think usually the students will miss the region. So I will erase this. Always and always double check. See here, this is our region. Is it bounded above by y equal ex? Yes, ex is the top. And he said bounded below by y equal x? Yes, and bounded by the sides x equal to 0 and x equal to 1. This is very important to do this. Now let us write y equal ex. It is very important. Y equal x. It's good also to remove maybe this. Now, what is the area according to our formula? Area is equal y top minus y bottom dx. I will write it so that you memorize the definition. Evaluated from A to B. Question for you. What is the top function here? Clearly it is what? Ex. Minus what is my bottom function? It is x. And here dx. I need to evaluate from where to where? Look at the region. This is very important. What is the smallest x in the region? In the x-axis? 0. What is the largest x in the x-axis for the region? It is 1. So integrate from 0 to 1. Is it clear? This is very important. Don't say it is 0, 1 from the question. Usually the question will trick you. Now this is a simple job for you. To integrate this is just for fun. I will do it quickly. This is ex minus x squared over 2 evaluated from 0 to 1. Now evaluate at 1. You will get e minus 1 over 2. Close the brackets. Minus, please do not forget to substitute by 0. At 0 you will have e to the power 0, 1. Minus 0 if you wish. And close the brackets. You will get e minus 3 over 2. And that is the answer for this nice exercise. Here I have a quick note. You remember at the beginning of this course, we discussed the area problem. At that time, we were not able to find the area exactly. We used rectangles and we approximated. Now, by the help of fundamental theorem of calculus, we are able to evaluate the area exactly. Here you have a question. He said the graph is not given in the question. No, we will not give you the graph. You need to graph it yourself. Also, we have another question. He said the first equation is the top. No, you need to graph and see. So I repeat myself for the third time. Always and always you need to graph. It is good for us to open a PowerPoint file called Common Graph. Good. Now let us recall basic functions. First one is y equal x squared. This is a parabola and you can graph it this way. Also, let us see the parabola y equal x squared plus 2. How can we graph this? It is the same as this, but you have plus 2 here. This plus 2 will give you the shift upstairs by 2 units. Now, see here, y equal x square. What about if we have the other way around, x equal y square? Well, it is a parabola, but it is opened to the right. You know this maybe from prep year, x equal y square, it is not a function, right? Because if you apply vertical line test, you will have intersection at 2 points, 1 and 2. Now, if you take square root for both sides, you will get y equal root x, plus and minus. This is y equal plus the root. Here we have similar one, y equal root x plus 4. It is the same as this one, but see here, we have only what? Shift 4 units to the left. You remember, x plus 4, if you equate it with 0, you will have x equal minus 4. That means the graph will start at x equal minus 4. Y equal e to the power x. I told you this in the previous question. It's like in Arabic حرف الراء. Also we have y equal ln x. The graph is given this way. You need to know these graphs. Now let us see y equal 1 over x. The graph is given this way. I think this is clear for you. You can see that we have a vertical asymptote here and a horizontal asymptote for this graph. Now it is the same story if we replace x by x plus 1, for example. You will shift what? The vertical line x equal to 0 and you make it x equal to minus 1. Good. What about if we have y equal 2 over x? It is the same as y equal 1 over x, but you have stretching here. For example, here, this point is what? 1, 1. But here, if you substitute, for example, if x equal to 1, substitute, you will get 2 over 1. So the point will be what? Will be 2. I hope it's clear. Good. For sure, there is no intersection. I hope it's clear. Good. Now let us see y equal x cubed. This is a familiar one. This is increasing function, and the graph is given this way. Now let us see the half circle. This is easy for us. This is minus 1, 1, and this is 1. And this is a half circle. Y equal root 1 minus x square. Good. Also, we have the graph of y equal 1 over x square plus 1 in the denominator. And the graph is given like a bell shape. In Arabic, al-jaras. This point is 1. Why? Substitute by 0, for example. You will get 1 over 1, which is 1. Why do we need this graph? Maybe this is new for us. If you integrate this function, what do you get? You will get tan inverse. Good. That is the reason for having this. Good. Now let us see trig functions. For example, let us see tan x. Y equal tan x. Tan x is given this graph. And please be careful. I am drawing one period from minus pi over 2 to pi over 2. And also we have sine x, cosine x. Please recall these from math 02. For example, sine x, the graph will be something like this. This is a rough graph. Sine will start from 0 and it will go this way. And it will go this way. Again, there is one period. There is 2 pi and there is pi. Good. But there is y equals sine x. And please do not forget x and y. Also, let us recall cosine x. This is very important. It is starting from 1 and it comes this way. Make sure these are on the same level. This is 2 pi and this point is pi over 2. You can check this. And this is pi and this is 3 pi over 2. And for sure the lowest point is minus 1. We have a question here. He said drawing is not needed because some functions are hard to draw. Well, to answer your question, in the exam we will give you something like these basic functions. So please, if you need an advice in this section or in this chapter, please draw the region. Let us see this nice question. He said find the area of the region enclosed by y equal x square and y equal to x minus x square. Well, you remember the first question, we gave you the sides x equal to 0 and x equal to 1. Those are the limits of the integration from 0 to 1. But here we do not say anything. We said it is enclosed by this curve and this curve. In Arabic كأنك تقول مقفل عليهم by this graph and this graph. Good. What shall we do in this case? First of all, you need to draw the region. Y equal x square, it is easy for us. Don't worry about this. Y equal to x minus x square. What is this? Is this a circle or what? Write in the chat. You have 10 seconds. Clearly, this is a parabola, open downward. The graph will be something like this. This is y equal minus x square. I mean, it will be this way. But how can we draw this carefully? As I said here, you need to find the x-intercept for 2x minus x squared. We need to solve this equation, 2x minus x squared equal to 0. Factor x, for example, you are left with 2 minus x equal to 0. Clearly, x equal to 0 or x equal to 2. Now, I think it is very clear for us. This is 0 and this is 2. That means our parabola will come this way. And for sure, you can continue this way and continue this way. But it's not needed for us. And he said, close it by y equal x squared. So this is y equal x squared. So what is my region? I hope you can see it. It is this nice region. It is very important. Usually in the exam, the students will miss this region. They will say, why don't you choose this nice region? Well, if I need this region, I will say the parabola y equal x squared and the other parabola 2x minus x squared, and I will say bounded by the x-axis. Be careful. Now let us write y equal 2x minus x squared, and this is y equal x squared. What shall I do? Do I need to integrate from 0 to 2? Be careful. I need to integrate from 0 to this number. What is that number? It is 1, but how can we check this? As I said here, find the intersection points. You need to solve these equations, y equal x squared and y equal to x minus x squared. This is y and this is y, so you need to equate both sides. I repeat myself, if you have y and y, equate both sides. Otherwise, you need to substitute this equation into the other one, or vice versa. So here, we need to solve x squared equal to x minus x squared. Put everything on the left-hand side, you will get 2x squared minus 2x. This is a simple equation again. Take 2x, for example, common factor, you are left with x minus 1, which is equal to 0. So either x equal to 0 or x equal to 1. Now it is very clear. This is x equal to 0 and this is x equal to 1. Now if you need this point specifically, you will say it is 1 comma what? Substitute here or here. So if we put it here, we'll get 1. So this point is 1. Similarly, if you put it here, you will get 2 minus 1, which is 1. Alright, now let us evaluate the integral. The area A will be what? The integral of what? What is the function? It is 2x minus x squared. Minus, what is my lower function? It is x squared dx. Evaluated from where to where? From 0 to 1. I repeat myself for the second time. dx means integrate from smallest x in your region up to the largest x in the region. See here, this is my region. What is the smallest x value? It is 0. What is my largest x value? Read it this way. Assume you have a pen like this and move this way. What is the last x in the region? Read on the x-axis, it is 1. So integrate from 0 to 1. This is very, very important. This integral is simple. I will just write 2x minus 2x squared. This is x squared minus 2x cubed over 3 evaluated from 0 to 1. This is just for fun. This is 1 minus 2 over 3. If you put 0, everything will be 0. So the final answer will be 1 over 3. The area of this region is equal 1 over 3. Here we have a question. He said, can I determine the interval without the intersection? How can you do it? You need to find the intersection. So these are steps. Draw the region and find the intersections using algebra. Now I will give you 1 minute to solve this question. It is taken from the old exams. He said, find the area bounded by this curve and the x-axis, x equal to minus 1 and x equal to minus 2. Take 1 minute, please. Alright, did you get the answer, which is ln 2? Okay, let me solve this question. As we said, this is the graph y equal 1 over x. This is the x-axis, x equal to minus 1, x minus 2. This is minus 2 and this is minus 1. Be careful, he said close it by x equal minus 2 and this is x equal to minus 1. Now, where is my region? Clearly, it is this one. The area will be what? Can you tell me what is the top function? It is y equal to 0. So please write this way. 0 minus what is my lower function? It is 1 over x. From where to where? What is the smallest x? It is minus 2. What is the largest x? It is minus 1. So integrate this way. Minus 2 to minus 1. This is very simple integral. Minus ln absolute value of x evaluated from minus 2 to minus 1. Now, let us take this minus outside. If you plug minus 1, you will get ln minus 1 inside the absolute value for sure. Minus ln absolute value of minus 2. These are very simple computation. Ln minus 1 inside the absolute value is 0. Minus with the minus will be plus. Lane absolute value minus 2 is lane 2. So this is the answer. It is a very simple question. Good? Well, I will give you something from my experience. This question came in some old exams and some of my students missed this question. Why? They solved this question this way. They said, well, this is easy integral. It is, I don't need to graph. They said integrate 1 over x. From minus 2 to minus 1. They did it this way. And they get minus ln 2. Unfortunately, they chose minus ln 2 from the choices. This does not make any sense. How come you say the area is negative? In fact, the choice was written like this, ln half. And ln half is equal minus ln 2. So this is a disaster. So please do not choose any negative answer. This does not make any sense. So please graph. Once you graph, you will see this clearly. It is top minus the bottom function. Clear? Again, I will repeat this for the third time. See here, if I say, what is the height here? This is 0, for example, and this is minus 2. I mean on the y-axis. What shall you do? You will say 0, top minus bottom, which is minus 2. So the answer will be 2. So as long as you subtract this way, top minus bottom, you will get a positive quantity. If you integrate a positive quantity, then you will get a positive answer, as we said before. And this makes sense. Case 2, the area A between the curves y equal f of x and y equal g of x, and between x equal to a and x equal to b, where f and g are continuous. See this figure, there is f, there is g, and we closed by x equal to a and x equal to b. He said here, f greater than or equal g for some values of x, and g greater than or equal f for other values of x. That means sometimes f above g, sometimes g above f. Let us see this figure. If we divide this into 3 regions, I will say this is S1, this is S2, and S3. See here, what is the top here? It is the red function, which is f. And what is the bottom here? It will be what? It is g. So my area will be A1 plus A2 plus A3. So it will be top, that is f of x, minus the bottom function, which is g of x. We need to integrate with respect to x. From where to where? Read the values on the x-axis, please. From A to C1. This is the first one. What is the next one? It will be the other way around. G is above f now. So I will say g of x minus f of x dx. From where to where? Read the x values. From C1 up to C2. We are not done yet. Plus, what is the last one? It will be from C2 up to B. Read here. What is the top? Now it is f, and the below function, it is the black one, which is g. So I will say f of x minus g of x dx. So this is case number 2. So you just split at the intersection points. What does this mean? This means that a will be the integral of the absolute value f of x minus g of x dx. From where to where? From a to b. That means if you open this absolute value, for sure, either you will get f minus g or g minus f. This is f minus g. This is g minus f, this is f minus g. How can we split f minus g or g minus f? For sure, you need to see which one is greater than the other. That means which one appears on the top. Good? That is the idea of case number 2. Let us apply it on some examples. Question 2. He said, find the area of the region bounded by y equal sine x, y equal cosine x, x equal to 0, and x equal pi over 2. First, we need to draw the region, then we will find the intersection points. Let us recall the graph of y equal sine x. This is the graph of y equal sine x. It will start from 0 and it will go this way. For sure, I draw only one period. So in this exercise, we need from 0 to pi over 2. So we need this portion. From 0 up to pi over 2. Good? And also we need cosine x. See it here, please. This is y equal cosine x. You know this. The maximum value is 1 and the minimum value is minus 1. Again, we need from 0 to pi over 2. So we need this portion of the graph only. As I said, we need to draw the region. First, let us start by y equal cosine x. Let us assume this is our one. And let us go up to pi over 2. Remember, cosine pi over 2 is 0. And also we need sine x. So this is y equal to sine x. Again, we need to have the same maximum. So you need to go this way, up until the maximum. Also, do not forget, he said, please close it at x equal to 0 by a vertical line and close it by a vertical line at x equal to pi over 2. Good. These are not are triangles. It should be a curved. But my graph here is not accurate. Where is the region? For sure, this is the first one and this is the second one. What's next? We need to find the intersection point. Clearly, there is an intersection here in the middle. What is that? It's pi over 4. It is not necessarily to be the average. You need to figure it out. Well, I will say y equal to sine x and y equal cosine x. See here, you have y. That means you can equate them. Sine x equal cosine x implies, how can we solve this equation? Divide by cosine x for both sides. You will get tan x here. Divide by cosine x, you will get 1. What is the solution for this equation? Well, we have infinitely many, but I am interested in this period from 0 to pi over 2. What is that? That is x equal to pi over 4. Check. What is tan pi over 4? It is 1. So this is pi over 4. Label the graphs. This is y equal cosine. And what is this? This is y equal to sine. Y equal cosine. What is the area? What is the top function here in this part? It is cosine. So I will subtract this way. Cosine minus the lower part, which is sine. From where to where? He said integrate with respect to x. That means read the values in the x-axis from 0 up to pi over 4. Plus the other way around now. What is the top function? It is sine x. What is the bottom function? It is cosine. So I will integrate sine x minus cosine x dx. From where to where? Read the values in the x-axis from pi over 4 up to pi over 2. And these are simple integrals. This will be sine x. Minus. What is the antiderivative of sine? It will be minus. So it will be plus here. And here I have cosine x evaluated from 0 to pi over 4. Same idea here. We will have minus cosine x minus sine x evaluated from pi over 4 up to pi over 2. Just evaluate. These are just simple computation. Believe me, the final answer will be 2 root 2 minus 2. Is it clear? Here we have a question from Osama. He said, can we say to A1, if you are sure that A1 is equal A2, then that's it. Calculate one of them and multiply by 2. Well, in this case, yes, they are the same. This region is equal to this region. So calculate one of them and multiply by 2. You may try this at home. Just calculate the first integral and multiply by 2. For sure, you will get the same answer. But be careful. If they are not the same, you need to calculate this integral alone plus the other integral alone. If you need the details of the solution, you can find it here in my notes. And the link is given in the description. Let us see case number 3. Case 3, he said, some curves are best treated by regarding x as a function of y. If a region bounded by curves x equal f of y, x equal g of y, y equal to c, and y equal to d, where f and g are continuous for sure, see this curve here, or you may see it here in a big shape. This is x equal f of y, this is x equal to g of y, this is y equal to d, and this is y equal to c. He said also f of y is greater than g of y for y between c and d. What does this mean? F of y greater than g of y. That means f of y is appearing on the right of g of y. For example, assume there is 1, there is 2, there is 3. For sure, if you go on the right, the x value will increase. So when we say f of y greater than g of y, that means f of y is appearing on the right. So what shall we do in this case? Well, you can do the same idea. You draw a typical rectangle like this. And you find the width and the height. The height will be what? It will be this x on the right minus x on the left. And what is the width here? It will be delta y. It is the opposite way of what we did in case number 1. The integral will be the function on the right minus the function on the left. So it will be f of y minus g of y. And we need to integrate with respect to y. Again, since we write dy here, integrate from small y up to big Y. What is small y here? It is c. What is the big Y? You can see it is d. And also, if you have dy, this means that you need to solve for the other variable, x. Why did I say solve for the other variable? Because you need x on the right and you need x on the left. I can summarize this as x on the right minus x on the left, dy from C to D. Okay, so this is the rule for case number 3. Let us see some examples. Question 3. He said find the area bounded by the curve y equal root x, y equal to 0 and x equal to 4. Well, this question we will solve it using method number 1, I mean y top minus y bottom, and we will solve it by method 2, which is x right minus x left. If you understand this question, then you understand the whole section. So please concentrate. First step, you need to draw the region. Y equal root x. This is not difficult. Y equal root x. He said y equal to 0, which is the x-axis. So please close it from this side. And he said close it at x equal to 4. So this is my region. You remember this is 4. What do you think about this point? It should be 4, 2. If this is not clear to you, remember this is y equal root x. If x equal to 4, plug it here, you will get 2. So this is the point, and I will write 2 here in the y-axis. We will apply y top minus y bottom. The area here will be, what is y at the top? It is root x. What is y at the bottom? It is 0, dx. From where to where we need to integrate? Since he said dx, then you need to integrate from the smallest x. Read the values in the x-axis. That is 0. What is the largest x value here in the x-axis? It is 4. So this is from 0 to 4. I mean the largest value in your region, which is 4. This is very simple integral. X to the power half. So if you integrate it, you will get x to the power 3 over 2. And multiply by the reciprocal, which is 2 over 3. Evaluated from 0 to 4. If you plug 4 here, check please. You will get 4 to the power 3 over 2. Give me the root first, which is 2. Put power 3, you will get 8. So just multiply 2 over 3 by that number, which is 8. If you check this, you will get 16 over 3. For sure, I didn't substitute by 0 because it will be 0. This is very clear. Now let us see method 2, which is x right minus x left. Again, you need to graph. You remember, when we say x right minus x left, we need to solve for x because you need x right minus x left. What is the x on the right? See this way and tell me what is x on your right. Clearly it is x equal to 4. What is x on the left? It is this blue part. It is y equal root x, but x equal to what? That means solve all the equations for x. So you will get x equal y square. My x on the right is 4. What is my x on the left? It is y square. Integrate with respect to y. Again, since we say dy, integrate from the smallest y in the region. What is that? It is 0. What is the largest y in the region? Read it please. What is this? It is 2. And this is very simple integral. I will do it quickly. This is 4y minus y cubed over 3 evaluated from 0 to 2. If you do this, you will get 8 minus 8 over 3. If you plug 0, you will get 0 for sure. And believe me, you will get 16 over 3. This is the answer for this exercise. If you have any question, please ask now.
Doctor, method 1, why you use another variable, dx? Why you didn't use y, for example?
No, be careful, be careful. Let us recall this. This is very important. Recall, case number 1, we said y top minus y bottom dx. And they said you need to solve for y. Why do you need to solve for y? See please here. If you solve for y, then what do you get here on the right hand side? You will get a function of x. So if you plug it here, you can integrate respect to x easily. Similarly here, when we say x right minus x left, dy, I wrote here solve for x, y. What is the reason? Because I need x right and we need x on the left. See here, if you solve for x, what do you get here on the right hand side? You get a function of y. So the integral will work smoothly. I mean, this is y squared and this is dy. But if you put root x, how come you put root x and you integrate respect to y? There is a mistake. Be careful. And since we say dy, then you need to integrate from the smallest y in the region up to the largest y in the region. Be careful. If you integrate in the exam from 0 to 4, you will get another answer. That's totally wrong. We have a question here. He said, choosing the method depends on the question, right? Well, yes, it's correct. I choose this example carefully because we can solve it using method 1 and method 2 easily. In the exam, you may have situation like this. Using this method, it will be difficult, and if you use this method, it will be easy. So please choose wisely. Next exercise, he said find the area enclosed by the curve y square equal to x plus 6 and the line y equal x minus 1. First step, you need to draw the region. Next, you need to find the intersection points. It is a parabola open to the right. Is this clear? Recall this. Y square equal to x. There is a parabola open to the right. Good. But he said 2x plus 6. How can you adjust this? Well, let us see it this way. It is y square 2 times x plus 3. This means that you have a shift to the left by what? 3 units. So the graph will be something like this. You shift everything. For example, this point, it will be shifted here by 3 units. You will have minus 3 here, and the graph will be something like this. Is this clear? For sure, the number 2 will stretch or shrink. It will be stretching for sure in this case. So this is the graph of y square equal to x plus 6. This is minus 3, and you need to go this way. And for sure, you need to go this way also. He said also y equal to x minus 1. This is a line, just give me 2 points. If x equal to 1, what do you get? You will get 0. So this is 1, 0. Now let us substitute by minus 1, for example. If x equal to minus 1, what is the value? You will get minus 1, that is minus 2. In fact, I cheated a little bit because I already put this point in the graph, this and this. This will be the line. For sure, this point will be 5, what? 5, 4. You will see this in the intersection. Where is my region? It is this nice region. Now, to find these points carefully, let us find the intersection points. Well, y equal to x minus 1 and y square equal to x plus 6. How can we solve these equations? Be careful. Do not say x minus 1 equal to 2x plus 6. There is a mistake. See here. This is y and this is y square. You need to have y square and y square so that you can solve. So I will write a small step here. Y square equal x minus 1 square. I am just squaring both sides. Now you have y square. Then equate the right hand sides. So I will say x minus 1 all square equal to x plus 6. If you solve this equation, believe me, you will get x equal to minus 1 and x equal to 5. I will do it here on the right. Expand. This will be x square minus 2x plus 1 equal to x plus 6. Put everything on the left. You will get x squared. There is minus 2x, and please bring this here, you will get minus 4x. 1 minus 6 will give you minus 5 equal to 0. How can you solve this? You can do it by factoring. For example, you will get x minus 5, x plus 1 equal to 0. Double check. Minus 5 times plus 1, you will get minus 5. Add minus 5 plus 1, you will get minus 4. That means my factoring is correct. So you will get x equal to 5 and x equal to minus 1. So I gave you these values. Now let us find these. This is minus 1, what? Substitute here, for example, you will get minus 2. This is 5, what? Substitute here, 5 minus 1, you will get 5, 4. Now I will apply x right minus x left method. Before we solve, what is the right? Clearly it is the line. What is the left? It will be the parabola. Is this clear? What is x in the right? See here, there is y equal x minus 1. Solve for x. You will get x equal what? Y plus 1. And what is x? Here, solve. I think this is not difficult for you. Y square minus 6, then divide by 2. So the final answer will be y plus 1. This is x right minus what is x in the left? It is y square minus 6 over 2 dy. Is this clear? Now I will ask you in the chat. I need to integrate from where to where? The final answer is 18. We have an answer from Nasser. He said from minus 2 to 4. Do you agree with Nasser, ya shabab? Yes, he is correct. The answer will be minus 2 to 4. I repeat myself for the third time. See here, when we say dy, then please read the values on the y-axis. So what is the y values here? It is minus 2 and this is 4. If you integrate top minus bottom, for sure you need to read the x values, minus 1 and 5. Is this clear? Now let us see the other method, which is top minus bottom. Well, before we solve, let us be careful. What is the top function? Clearly, it is the upper part of the parabola. Now, what is the bottom function? Sometimes it is the lower part of the parabola, and sometimes it is what? It is the black line here. So what shall we do in this case? In this case, you need to split by a vertical line. See here. Now, on the left of this line, the top will be the upper part and the lower will be the lower part of the parabola. After this line, I mean on the right of this line, the upper part is the upper part of the parabola. And what is the bottom? It will be the black line over here. Remember, in top minus bottom, you need to solve for y, because you are saying y top minus y bottom. So what is y top here? If you solve this equation, y equal plus or minus the root. The upper part will be plus the root. The lower part will be minus the root. I repeat myself because this is very important. The upper part will be plus the root. The lower part of the parabola will be minus the root. You can say this is A1 and everything here, let us call it A2. The final answer will be A equal, the top function is 2x plus 6 under the root. Minus, what is the lower function? It is minus the root dx. And as I said, dx means integrate from smallest x. This is minus 3. I hope you remember this. And what is the largest x in this region? Read it here from this point. What is this? It is minus 1. So you need to integrate from minus 3 to minus 1. Plus, what do you think about the other part? The upper part will be root 2x plus 6 minus. What is the lower part? It is the line, which is x minus 1 dx. From where to where do we need to integrate? Again, from minus 1. What is the largest x value? It is 5. And that's it. If you evaluate these, believe me, you will get the answer to be 18. The calculation in this method is much more involved. That means we split the integral in two parts. Not only this. How to evaluate this integral? You need to use a substitution. And for sure you will take time. So this method is not recommended. Note number 2, he said the calculation in x right minus x left method, which is the previous one, is much easier. So this method is recommended. So what is the final point here? If you graph, you will have the freedom how to move. Whether you use x right minus x left or y top minus y bottom. So please graph so that you understand things. This is the end of section 6.1.